Aritra, do you hear us?
Yes, I can hear you. You can't hear me?
Great, great. Okay, so we are going to start now the second part of the afternoon session. So we start with a flash talk. The first flash talk is given by Aritra Ghosh on studying morphology and quenching of galaxies in the all-sky era using interpretable Bayesian convolutional neural networks. So you have 4 minutes.
Thank you. Hello, everyone. I am Aritra Ghosh, and today I will be talking to you about studying the morphology and quenching of galaxies using Bayesian CNNs. Now, as all of you are aware, we have been studying morphology using CNNs for quite a while now, but there have been a few challenges associated with the process which have remained. The first one being that there has been a lot of work on morphology classification, but not nearly enough on parameter estimation. And with that comes the challenge of estimating reliable uncertainties when you predict morphological parameters. Next is the question is how can you do this entire process with using a small amount of real training data, keeping in mind future unanalyzed surveys. Next is this idea that CNNs are absolute black boxes and therefore the results that come out of them are uninterpretable. And lastly, a question which many people seem to ignore is how can we use the same CNNs to study AGN host galaxies? And to answer some of these challenges, we have developed a machine learning framework, which we call Galaxy Morphology Posterior Estimation Network, or GaMPen. Now, GaMPen consists of a set of fully connected and convolutional layers, but it is preceded by a spatial transformer network, or STN. What the STN does is that it helps us it makes a transformation on the input image, which is helpful in the downstream task. For us, what this looks like is that even in crowded fields, the STN assists the network in focusing on the galaxy of interest at the center of the image. And the best part is the STN does not need any extra supervision during training. It trains along with the rest of the network. Now, to train this entire framework with a very small amount of real data, what we do is we first train the network on a large amount of simulations and then fine-tune the already trained network using a small amount of real data. Now, once you have trained the entire framework, when you feed an image into the network, what you get is 3 different distributions for the bulge to total light ratio, the effective radius, and the total flux. Now, to predict these uncertainties, what we are doing is we are combining both epistemic and aleatoric uncertainties. We are getting the epistemic uncertainties because we are using a Gaussian log likelihood as our loss. And for the aleatoric uncertainties, we are using Monte Carlo dropout. Now, on this slide, I've just shown one galaxy, but if you do this for all the galaxies in our data set, you can then ask the question, what fraction of the time is the true value within the central X percentile of the predicted distribution? And if you pick the correct dropout rate, which is a tunable parameter, because we're using Monte Carlo dropout, you end up with uncertainties which are pretty well calibrated. Lastly, I will show you the results that we obtained for hypersupreme CAM low redshift real data. And as you can see, the residuals for all the 3 output variables are pretty well centered at 0 and have reasonable spreads. And I don't show it to you here, but the residuals, if you ask me where are the residuals higher, they're higher for fainter and smaller galaxies, but are still very reasonable at this redshift range. So summarizing, I showed you how GaMPen can be used to predict posteriors for morphology parameters with minimal real training data. What I did not tell you about is how we have performed tests of interpretability and also use this to study quenching and how we are using GaMPen to study AGN host galaxies. To know about the first two, please have a look at my poster. The poster QR code is given, and for the later one, you can speak to me. And lastly, GaMPen will be public very soon after further testing. However, if you want to use it now, please get in touch with me. And with that, thank you very much for your attention.